the largest and most massive planet in the solar system. It is truly a wonder. Come with us to take a deeper look at the king of the gods, Jupiter. Jupiter has a mass of 1.90 times 10 to the 27th kilograms. That is 318 Earths. Its diameter is 142,984 kilograms, 11 times that of Earth. They don't call it a gas giant for nothing.
But how did this come to be? How did Jupiter get so big? We have to go back to find out.
We call it a frost line. It's located where the asteroid belt is present day. The frost line is a division between volatile elements that are gaseous from the ones that are solid. Jupiter was formed closest to this line, a region with a high density of matter than others. Since it was so close to the frost line, it grew first and fast. It rapidly took lots of the material, including large amounts of hydrogen and helium gas. The moons were also formed at this time, and today we have 67, Io, Europa, Ganymede, and Callisto being the most famous ones. We'll explore the main moon's layer, but for now, let's explore the fascination of the Great Red Spot.
The storm inside of the infamous Great Red Spot is called an anticyclone. Anticyclones are the opposite of hurricanes and other low-pressure systems on Earth. The Great Red Spot is a large elliptical storm enough to contain 2 Earths inside of it. However, the red spot is shrinking. At one point, it was 25,000 miles across, and now it is only around 10,000 miles across. Nonetheless, it is a permanent feature of the planet and crucial to Jupiter's identity. That's not the only thing crucial to Jupiter's identity. Now let's discuss the principal components of the planet Jupiter.
The atmosphere of Jupiter makes up the entire planet. It is composed almost entirely of hydrogen with a few traces of other gases. The atmosphere of Jupiter is 90% hydrogen. The remaining 10% is almost completely made up of helium, though there are small traces of other gases inside. Going from the outermost edges of Jupiter toward its center, you will find that the pressure and temperature goes up. The increases causes the gas to separate into layers. The bottom of the atmosphere surprisingly has the same pressure as Earth, 1 bar. The surface layer on Jupiter is known as the troposphere and extends to approximately 50 kilometers above the surface. The troposphere contains ammonia, ammonium hydrosulfide, and water, which causes distinctive red and white color seen from Earth. As you move higher in the troposphere, the temperature drops, ranging from minus 260 degrees Fahrenheit, minus 160 degrees Celsius, to minus 150 degrees Fahrenheit, minus 100 degrees Celsius.
The next layer is the stratosphere. It extends to almost 200 miles, 320 kilometers, above the surface. Here, temperatures start at minus 260 degrees Fahrenheit and rise to approximately minus 150 degrees Fahrenheit. The stratosphere and troposphere are both warmed by the sun and planet's interior, and gets hotter as you go up. The thermosphere lies on top of the stratosphere. Temperatures rise to approximately 1,340 degrees Fahrenheit, that's 725 degrees Celsius, at heights over 600 miles, 1,000 kilometers. The thermosphere can also emit a weak light known as airglow. This keeps the night sky from being completely dark. The thermosphere is heated by particles from the magnetosphere as well as the sun.
The outermost layer of Jupiter's atmosphere is the exosphere, where gas particles can escape into space. With no clear boundary, the exosphere bleeds into interstellar space. Scientists use changes in the temperature and pressure to determine the various atmospheric layers with high detail.
The core, however, is somewhat of a mystery. The best guess we have today is that it is an extremely dense mass spanning about 12 to 45 times more massive than Earth's. Underneath the rocky surface might be a various amount of ices. However, just because there's ice does not mean it's cold. It's actually believed that Jupiter's core is 22,000 Kelvin. That's over 39,000 degrees Fahrenheit. It is also possible that the core has a pressure of 70 million atmospheres. Saturn isn't the only planet with rings. Jupiter has some as well, 4 to be exact. 1 primary ring, 2 gossamer rings, and a halo ring. The halo ring is the closest and most thick in Jupiter's ring system, but interestingly, it isn't nearly as dense as the others. This has a lot to do with Jupiter's magnetic field. It excites the dust particles into an energetic orbit, and the main rings are made up of the particles from the inner moons, Metis and Andrasta. They are close and small enough that forces from Jupiter slowly pull off their material. Now, let's transition to a discussion of Jupiter's main moons. Io, Callisto, Europa, and Ganymede.